Hello, this is Mukherjee. I am the captain of the team named ODDIE, and here are my group members.
Hi, my name is SOUVIK Pan.
Hi, I am CHAKRABORTY.
Hi, I am ROUNAK GHOSH.
We present our project under the theme Social and Infrastructure, titled as Smart Urban Public Water Management System.
The aim of this project is to distribute water efficiently to various public sources through a smart IoT-based system.
Our system caters to the demands of the consumers along with ensuring the minimum wastage of the precious resource.
It also incorporates various newer designs to ensure proper maintenance of the prevalent water distribution system.
Considering the ever-growing population all over the world, with India providing one of the largest contributions, the demand for fresh water continues to escalate. Besides, what worsens the situation is the fact that our Earth's reserve for fresh water is mere 2.5%, and on top of that, there is continuous overexploitation and wastage of the resource. Freshwater being a non-reproducible exhaustible natural entity, it is a matter of concern for the entire population since it is one of the basic amenities for survival. Public water facilities are one of the largest providers of fresh water in any country and also one of the prime means of its wastage. The prevalent public water management and distribution system doesn't keep any track record of water usage and its consumption. Thus, it becomes one of the prime reasons for failure in detection of water wastages and overexploitation. It quite often neglects the various quality standards that must be ensured for drinking water, thus leading to severe health problems among the consumers. Thus, newer ideas and plans are needed to detect and minimize wastage and ensure better water quality standards. Our solution consists of a closed loop system which gathers relevant data. Now, coming to the prevalent situation of public water systems in India. Here, by public water bodies, we are trying to focus on the water supplies at public places like bus stands, railway stations, and in localities which are open for all public. The problem with all these systems is that there is no technology involved to track the water consumption, and therefore a lot of water gets wasted due to ignorance of the consumers or due to pipeline leakages. Thus, these leakages further leads to the contamination of the water, becoming the source of various waterborne diseases. Also, in India itself, there are quite a few places which have water supplies but no proper system mechanism to control the water flow. Thus, during the period of water supply, a significant amount of water gets wasted. Consumers quite often, while utilizing the public water supplies, keep the taps running, which is another source of water wastage. For public water facilities based on groundwater, this can prove to be extremely deteriorating for the groundwater levels. Also, to replenish these groundwater levels, it takes a significant amount of time. Now, this was all about the maintenance of public water facilities. Now, let us throw some light on the distribution of water in India. Distribution of water in India acts like an open loop system. It doesn't take into account the current rush and demand to route water. It supplies water on the basis of a daily time loop in a fixed quantity. The drawback with this system is that places which don't have a huge rush, the water provided is in excess, and places where rush is high, the quantity of water that is provided cannot fulfill everyone's need. Thus, to tackle the situation, a dynamic water distribution system is required which can collect data about the rush hours of each and every public water facility and route water accordingly. Also, in places where the availability of water is scarce, the water that comes from various public water facilities don't comply to to various quality standards, thus jeopardizing the lives of the consumers. Also, changes in quality of the water are not tracked. Now, coming to the consumer side of things, people who are dependent on these public water facilities for drinking, washing, and other household purposes have to travel long distances to fetch water, and quite often they have to confront long queues. This becomes a major reason for harassment of the public. Therefore, consumers need a better system which can update them with all the places where water is available and also the current rush of each of these places. Then select the best among these, which would be the nearest and has the least rush.
To overcome all these problems, we have proposed a solution in which all the public water facilities are equipped with a digital interactive system which is capable of sensing various parameters, perform some control mechanisms according to the parameters, and also can send and receive data to a remotely located cloud server. It receives the data of the volume of water that is being consumed by each tap on a regular basis and transfers this data to a local cloud server. This local cloud server is capable of predicting the rush hours at each of the public water bodies. With the rush hours being detected, a proper signal is sent to the public water facilities which are fitted with a latch mechanism. This latch mechanism plays a fundamental role in routing the water supply. It has a capability of reducing or increasing the water supply to the public facility according to the consumption. Places which have greater rush, the latch mechanism opens the pipe orifice to a greater extent, and in places the crowd is lower or not present, the pipe orifice is opened to a smaller extent. This system helps in proper distribution of water according to the need of the situation or people. The cloud latch mechanism also helps in reducing the overexploitation of water by particular individual body. If an excessive amount of water is being drained out from the system due to leakage or malfunctioning, it can be very easily detected and the system can be stopped from functioning by closing the water supply through the latch until the proper conditions are restored. Thus, this system helps in detection of faults in a much faster rate so as to reduce the wastage, and also intimates the administration personnel of the location where maintenance work has to be done. For places which are dependent on groundwater resources, this consumption analysis plays a vital role in keeping the groundwater levels under a check. Now coming to the site water facilities where the digital system to be fitted. The facility is smart enough to take some control actions by itself. It has a human detection sensor system which is capable of detecting human presence. This is useful because if due to the negligence of the consumers the water remains open for a long time and the water drains out without being stored in any container, in the absence of the human, the latch mechanism again cuts off the supply. This supply is regained once a human is again detected. Also, various water purity parameters like dissolved oxygen levels, halide contents, particles, contents are being detected various water purified sensors. This end checkup of water is extremely useful to ensure clean and safe water is being provided to a customers. It will play a fundamental role in reducing the waterborne diseases. The sensor data is sent to the cloud through a Wi-Fi. Wi-Fi is our preferred mode of data communication because most of the public water facilities in areas like bus stand, railways, banks, etc. have been provided with Wi-Fi routers. Thus, we try to take maximum advantage of the situation by utilizing these already available facilities. A report of the daily activities is being recorded in the cloud server on a daily basis, and inferences are drawn from the administration for what steps are to be taken next to ensure uninterrupted water supply to every citizen. The following proposed system is completely different from the conventional water supply. The daily data tracking of the consumption is vital in efficient water routing. Also, the inbuilt system on the taps ensure minimal amount of water which is being wasted and that the water purity maintains some strict standards for some consumption.
We will now focus on the hardware implementation of the model. The digital system mainly consists of a microcontroller which acts as the brain of the local system. It is connected to the sensors which detect the water purity and human detection. For water purity testing, we have used sensors like halide level tester, dissolved oxygen sensor, and water solid particle level sensor. For human presence detection, we have used a combination of IR sensors and PIR, which is the passive infrared sensor. All the sensor is being read by the Arduino. The Arduino also controls the latch mechanism according to the sensor values. If the human detection sensor detects human presence near the tap, the latch opens the pipe's orifice and keeps it open. If the human is not present and water drains out without any storage, the orifice is closed to prevent further wastage. To measure the volume of water that is being consumed, we have utilized a water flow sensor which gives the water flow rate, and with an inbuilt timer control we can determine the volume of water that is being consumed by the system in a given interval of time. For the latch mechanism, we have used a solenoidal valve which is controlled by Arduino with instructions from the cloud. Another sensor which is of vital use is a water gauge pressure sensor, which detects the human gauge pressure difference between the local pipe and the supply pipe to detect any leakage in the pipe that might have occurred in the water route. The sensor data are sent to the ThinkSpeak cloud using NodeMCU, which is a Wi-Fi based microcontroller. The NodeMCU microcontroller connects to the nearest Wi-Fi public hotspot and sends the data to the cloud. This model with all its sensor data now needs to be trained in the cloud for months to retrieve the pattern of water consumption. It also learns about the water purity standards that needs to be maintained and can easily detect any departure from the standard. After this training period, it can be deployed and now it can easily detect the peak rush hours and route the water efficiently.
Now we will show you the Arduino code that we have written for all the sensors and the latch mechanism. As you could see here, these are all the pins for the sensor: the PIR sensor, IR sensor, the dissolved oxygen sensor, halide sensor, and the servo is our mechanism for implementing the solenoidal valve. Now, coming down, you could see that we have implemented a timer algorithm for the latch mechanism. Here we send the data to ESP8266, and here we calculate the volume of water that is being flowing out of the flow rate sensor. Here we are detecting the object and motion, and on that basis we are opening and closing the latch. This is the whole latch control mechanism and the algorithm. Now coming to our next code, here is the ESP8266 code. Here, as you could see, we have connected to the local router and we are sending the data to thingspeak.com, and here is the API key for our interface. Here we have connected to the Wi-Fi, and here we are sending the sensor data to the various fields of a single channel of the ThinkSpeak cloud server. So here you can see we have generated a random values for the consumption of water. So now if we run this code, this is for a single public water facility, say tap A. So if we run this code, you could see a graph is generated, random graph is generated on the usage of water for 7 days. Similarly, we have the same tab for tab B, meaning a second public water facility. Now running this code will generate another random value of data. Now for our algorithm to exactly match the water consumption rate on daily basis, we have created another code which you could see here, which tries to follow the curves of the daily consumption of water, as you could see here. This is the average consumption of tap A and tap B, and on the basis of that, the water is being sent to those facilities. So a dynamic routing system could be developed from here. Now coming to the user interface, we proposed two Android apps, one for the administration and one for the consumers. The administration Android app is connected to the cloud server, and the various inferences that are being drawn are sent to this app. This app is provided to the caretakers where they can visualize the water consumption rates, the water gauge pressure difference, and also the purity of water. Any malfunctioning in the above parameters are reported and detected in the app. The caretaker can decide whether to take any further step like cutting off the water supply for a desired interval, or let the inbuilt smart mechanism decide on its own. The caretakers are cautioned before time if excessive draining of water is taking place at the particular facility and what can be the cause of the same. Meantime, the administration can plan measures to take care of the system. For the consumers, we have developed an app which can help the individual to find a properly functioning public water facilities which is nearest to him and also has the least crowd. The shortest path algorithm based on the crowd population as weight measures are used for this purpose. The least crowd detection is based on Google Crowd Density Detection API. Now with app in hand, people don't have to wait for long hours in the queue to fetch water. It reduces the irritation level of the consumers. It will also provide the consumers with real-time purity levels of the water so that they can be assured that they are consuming a clean and pure water. We have created a small prototype for the simulation of the system. As you can see here, this bucket acts as a pipeline with a tap attached to it which acts as a public water facility. We have used NodeMCU and Arduino Nano as a microcontroller and Wi-Fi module. Now, this our second ESP8266 acts as a Wi-Fi router. Now, as you can see, let us consider that water has been filled in the pipeline, and this servo plus custom built latch acts as a solenoidal valve that controls the latch mechanisms from the signals coming from the cloud. Now, we will like to show you the working of the system. Here are the two sensors, the IR and the PIR sensor, which acts as the human detection mechanism system. Whenever we put the system on on mechanism, means we open the tap, and if it detects human presence, the water will flow continuously. As you can see here, the water is flowing continuously and the latch is open. But whenever this person will be out of the contact of the water body and the water will be flowing continuously, it will automatically close the latch system so as to conserve the water. Here, as you could see, are the various levels of sensor data that are being sent to the ThinkSpeak cloud. Here is the dissolved oxygen levels, the water consumption, the chlorine levels, the water pressure levels. Thus, these data are all real-time data which can be further used for MATLAB analysis. We would like to install 5 digital prototype of the system at 5 different public water facility if we are provided with the effective fund. The total sensor cost of the system is rupees 6,000 approximately. This includes the gauge pressure sensor, IR sensors, PIR sensors, flow rate sensor, dissolved oxygen sensor, and halide level detection sensor for water purity. The solenoidal valves will cost rupees 1,000 each. The microcontroller and the Wi-Fi module will together cost another rupees 1,000. MATLAB for simulation and ThinkSpeak Cloud standard version would cost a total of rupees 5,600. Since we are also calling Google APIs for crowd density information, the first 25,000 calls bear no cost, but after that, for every 1,000 calls, a charge of $0.5 is incurred. Thus, the total estimated cost of the single system will be around Rs 14,000 to 15,000. The total cost for 5 setup will be thus around Rs 75,000. Effectiveness of the project. With this project, by keeping a daily log of water consumption, we can route water to places according to the need, thus creating a dynamic feedback-driven mechanism which leads to effective utilization of water. We also target to reduce the water wastage due to consumer negligence and leakages with our in-house digital system at the public water facilities. In the current times, water conservation will play a very important role in shaping our future, and this project plays an important role in ensuring the same. We provide various preemptive fault detection mechanisms for the administration and the caretakers so that they can be alerted within the time limits about the signs of failures in the system and also the location where it might occur. In the current scenario, most of the times the caretakers are absolutely unaware of the faulty situations in the water supply chains, and thus this leads to a lot of water wastage and also consumer harassment. Last but not the least, we provide the customers with an interface with which they can easily locate water bodies for their need, and also with the added advantage that the directed water facility would be having the least crowd. Adding on to that, the consumers can also verify the real-time water purity levels and be assured about the water they are consuming. With all these features, we aim to build a system which can effectively save water and also meet the demands. We are very sure with this model we can provide a clean and pure water to every other individual, also taking care that it is not overexploited, thus together building a better future.
Thank you.